In this lecture, we are going to discuss about comparable and non-comparable topologies and finer and coarser topology. First is the definition of comparable and non-comparable topologies. Comparable and non-comparable topologies. Non-comparable topology. Let X be a non-empty set and T1 and T2 be two topologies on X. Then T1 and T2 are said to be comparable if T1 is containing T2 or T2 containing T1 and T1 and T2 are said to be are said to be are said to be non-comparable non-comparable if T1 not containing T2 and T2 not containing T1. Next, we are going to consider some examples on comparable and non-comparable topologies. Examples on comparable and non-comparable topology. Let X equal to A, B, C be three instants, that T equal to 5X, antecedent and X, they are trivial elements of a topology. Then you should consider A, B and B, C. Okay? Then this is not a topology because if I take union of these two sets, then this is X belongs here, but intersection, that is AB intersection BC, that is B does not belong to this set. So this collection will not be topology. This collection will be topology if I incorporate this element in the collection of subset of X, then this collection will be topology on X. Okay. Next, consider this is T1. Then again, consider T. T will be 5X A B. Then this is A B, and then this is B C. Then this is B. Okay. Okay, this is a set union of these two elements. It's this one. Intersection is empty set, and union of these two is AB. Then intersection of this will be empty set. Again, union of this with this and this will be ABC. This is X, and intersection will be empty set. Then union of this will be BC. Intersection will be B. Again, intersection will be B, and union will be ABC. This and this B was repeated. So this is like this. Okay. This is a topology on X. No need to check out two at a time, three at a time. If you are confused, then check it out. Use that technique. Now you can easily check that T1 is containing T2. Phi and X are member of T1 is AB is found in T2, and BC is found in T2, B found in T2. Moreover, there is one more element. So T1 is contained in T2. This implies T1 and T2 are comparable. Okay, T2 are comparable topologies. If I take another topology T3, T3 consists of, then see this topology T1 and T3. T1 T1 is not contained in T3, okay, and T3 is not contained in T1, okay. That means this T1 contained in T1. So T1 and T3 are non-comparable topology. Non-comparable. Okay? Non-comparable topologies. Again, you can say T2 and T3. Similarly, one can easily check out T2 and T3 are non-comparable topologies. Non-comparable topologies. Okay. Next, we are going to discuss finer and coarser topology. First, write the definition of finer and coarser topology. Finer and coarser topology. Finer and coarser topology. Coarser topology. Finer and coarser topology. Suppose T1, T1 and T2 are two topologies on X, then T1 is said to be finer than T2 or within bracket, or T2 is coarser, okay, coarser than T1. T1 is finer than T2, and T2 is of this is same. T1 is finer than T2, and T2 is coarser than T1 if 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 T2 containing T1, the T2 containing T1, and T1 is said to be strictly finer, said to be strictly finer if finer than T2, finer than T2, T2 if T2 is containing T1. Okay. Next, consider some example of finer and coarser topology. Example: consider x equal to a, b, c, and d. Okay, T1 T1 equal to 5x a c, then a c. This will be topology. A union C will be AC. Their intersection is antiset. So this is collection will be topology. Then consider this 5x A AC. Then take this B A union AC union AB will be ABC. Then take one more element that is ACC. Okay, C. A union C will be AC. AC union C will be AC. B union C will be BC. AB union C will be ABC. ABC union C will be C. Then check out for intersection. This intersection is content no. Here intersection is empty set. This intersection with this will be C. This intersection with this will be empty set. This intersection this will be empty set. This intersection with this will be C. This intersection with this will be C. T1 and T2 are topology and hence one can easily check out that elements in T are elements of T2 contained in element of T2. Phi, here it is phi, X, here it is X, A, here it is A, C, here it is C, AC, AC is contained in here in T2. Each element of T1 is a member of T2. That means T1 is contained in T2. This implies T1, T2 is fine here, fine here. Then T1, or we can also say T1 is coarser than T2. Okay, then T2, then T2. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.